Okay, in this problem, it says find the center of mass of a rod of length L whose mass density changes from one end of the rod to the other quadratically. That is, if the rod is laid out along the x-axis with one end at the origin and the other end at x equal to L, the density is given by rho x equal to rho naught plus rho 1 plus rho naught x over L squared, where rho naught and rho 1 are constant values. Okay, so what we have is a rod of length L. So this is the positive x direction. Okay, there is 0, there is L. Now, if the rod were uniform density, the center of mass, of course, would be right at the center at L by 2. But you can see that the density increases, assuming rho 1 is greater than rho naught. The density increases, so the center of mass should be to the right of this, assuming rho 1 is greater than rho naught. If rho 1 is less than rho naught, then the density is decreasing, and then it should be to the left of 5 meters. Anyway, okay, so the center of mass is given by, what we'll do is, the idea here is, so you break up the rod into little pieces. dm is the mass of this little piece, and x is the location of that piece. So the center of mass is given by x dm divided by integral dm. So that's the definition, and we'll have to do this integral. So now dm is the mass of that piece, is the density at that location, the density of that location times dx. So dm, the mass of this little piece, is the density of the rod at that piece times the length of that rod, which is dx. Okay, so that is dx. All right, so let's put all that in. So x center of mass is x times the density is given by rho naught plus rho 1 minus rho naught x squared by L squared dx, and the integral goes from 0 to L divided by 0 to L rho naught plus rho 1 minus rho naught dx. All right, so let me do the denominator first. 0 to L rho naught plus rho 1 minus rho naught x squared over L squared dx. So this integral would be rho naught x plus rho 1 minus rho naught over L squared x cubed by 3, and all this is evaluated between 0 and L. So this first term gives you rho naught times L, and the second term gives you this times L cubed. Okay, so this is equal to, so the denominator is rho naught L plus rho 1 minus rho naught L squared 3L squared L cubed. Okay, all right, let's add a page below. All right, so the denominator again is rho naught L plus, and you can see that L cubed divided by L squared is L, so plus rho 1 minus rho naught divided by 3L. Okay. All right, and this simplifies too, so you can simplify this. This simplifies to 3 rho naught plus rho 1 minus rho naught divided by 3 times L equal to rho 1 plus 2 rho naught divided by 3L. All right, so now let's do the numerator. So the integral that we're doing for the numerator is okay. X dx 0 to L. So this is 0 to L rho naught x plus rho 1 minus rho naught L square x cube dx. Okay, and so this is 0 x squared by 2 plus rho 1 minus rho naught L square x to the power 4 by 4 and 0 to L. So when you evaluate this, this is rho naught by 2 L square plus rho 1 minus rho naught by L square L to the power 4 by 4. Okay, so the numerator will work out to be rho naught by 2 L square plus rho 1 minus rho naught by 4 L square. Alright, so now we're going to put all of that together into the X center of mass. Okay. Okay, so the X center of mass is numerator divided by the denominator. So, okay, let me simplify this. Rho naught by 2 so actually this will simplify too. 4 rho naught 2 rho naught, so rho 1 plus rho naught divided by 4 L squared. So that's what that simplifies to. So the numerator is rho 1 plus rho naught divided by 4 L squared, and the denominator is rho 1 plus 2 rho naught divided by 3 rho 1 plus 2 rho naught times L. Alright, so X center of mass is and the X center of mass becomes, okay, I'll write it here, rho 1 plus rho naught 3/4 divided by rho 1 plus 2 rho naught times L. Okay, so let's make sure that we got this right. Okay, so let's look at some limits. If rho 1 is equal to rho naught, then the density is uniform. And if the density is uniform, it doesn't depend on x, the center of mass should be right at the center. It should be L by 2. So let's make sure that if rho 1 is equal to rho naught, this would be 2, so the limits, checking limits. if rho 1 equal to rho 0, then x center of mass is 3/4 2 rho 0 divided by 3 rho 0 times L 2, which is L by 2, as expected. Alright, so we got the right result. Okay, at least it has the right limit. So there's the center of mass. Okay, that finishes this problem.